Assalamualaikum and good morning, everyone. So today we are here to discuss about our presentation for project control and instrumentation. The code for the project is EMM 3520 and the subject name is instrumentation and control. So for the report title is PID controller for the water level control system. My name is Halvekimi B. Ismail. The matrix is 197551. Introducing my also my teammates which contributes very much for this project, which is Muhammad Rishad bin Muhammad Azwadi 196199, Muhammad Iqmal bin Maksaan 198725, and Muhammad Alif Aiman bin Muhammad Sabri, which is his number
Matrix.
is 197382. Okay. So for the introduction is my part. So I will deliver my speech right now, which is the definition of PID, which is known as the Professional Integral Derivative Controller. It is a tool used to monitor temperature, flow, pressure, speed, and other process variable that related to our industry. After that, PID control also use closed loop control feedback to keep the actual output from a process as close to the target or set point output as possible. The next is the PID water level controller is uh, is what we choose for our application, and it is available in our industry, and it is also one of the PID controller application. Okay, that's all for introduction. Next is the problem statement.
Okay, for the problem statement, uh, the first one is the process of reaching a specific level point of water is difficult to make. Here is the problem that we face. It is consists of high cost of smooth transition and response graph, and it is also difficult for human ability.
Sorry guys, sorry, my mistake.
From the previous statement, I have come to an objective. The objective is to control the water level rise by using a PID controller. This is also want to get the accurate water level measurement. Okay, that's all from me for now.
Okay, the next one is application.
Right, so for the application, we will use the water level control system to apply the PID control. So basically, this system will allow the users to set the desired level of water by controlling the amount of water flowing into the tank. So the user need to set the calculation and the parameters to the system so that the user has the power to choose the certain water level. This is because the PID controller is able to control and adjust by itself by the flowing of the water with the calculation and the parameters that will be entered by the handles, which is the user. So that's for the application. Thank you.
Okay, the next one is my part, which is working principle for the controller. For the controller is the process will start when the level of the water exceeds the limit. Then it will send a signal to the controller. Then the controller will having a counteract session in order to stop the water from exceeding the limit. So for the proportional tuning, it has basically controller have three components, which is proportional tuning, integrative tuning, and derivative tuning. So for the proportional tuning, what I can say it plays an important role in the controller due to having a function to be the main drive for the control loop. It also can be said that the value of the KP, which is for the constant for the proportional, can determine the value of the percentage error for the output. The next one is the integral tuning. This type of tuning can help to decrease the percentage of the output error in a system. By adding even a small error over time produce a drive signal large enough to move the system toward a small error. The next one is the cumulative of some small error can produce enough large drive signal to counteract the system to the smaller error. The next one is the derivative tuning. The last one, this tuning can help to counteract the value of the KP and KI when there is output change happens. However, it will not affect the error for the results. That's all from me. Okay, this is also my part. What we can see for the block diagram for the controller, we can have three gain blocks, one derivative block, one integral block, and one sum block. That's all from me.
Okay, next I will continue to the working principle of plant or system. Plant or system is the model used to control the system by a transfer function. The transfer function is in a mathematical formula. The plant is the main character of the system that will determine the output of the result. The block diagram below show example of the transfer function that is used for the plant or the system. Okay, next. Okay. In order to obtain estimated mathematical model, the system of the block diagram, the transfer function is given as the as the as the equation below. As you can see, the transfer function that we use for our system is in the right side, which is 168 per in bracket 120.38 second plus 1, where kV is the gain of the valve value. Okay, that's for me.
Okay, so I will proceed with the next component, which is actuator. So the working principle is, the function of the actuator is to regulate the direction and the duration of the output of the system. So basically, it will limit the input signal to the lower and upper saturation values according to the desired level. So based on the simulation of the MATLAB of this project, this actuator is represented by the saturation. So when the output signal exceeds the lower and upper bound that defined by the parameters, the signal will stop accept the transmission signal and it will automatically cut off. So the valve will close. So as you can see in the figures, that is the block diagram of the actuator. So next. So in order to make the actuator function, this is the transverse function that will apply in the simulation, which is hs equal to 0.5 divided by s plus 2. Okay, that's all from me.
Okay, as for the sensor, a sensor is a device that gives output signal based on the input signal. It basically converts a signal from any energy domain into electrical domain. The possible type of sensor to be used for this system is called capacitance level sensor. The sensor is suitable if the wall of the tank is made from metal, which use a single bar or insulated rod as a capacitor plate and the wall of the tank as the other. This type of capacitance has already been used in aircraft fuel quantity indicators, which suggests that it is suitable to be applied for this system. Capacitance switches can be utilized to provide non-contact point measurements of the water level. Okay, the figures below shows the sensor for this system, used for this system. Okay, next slide. Okay, check.
So these are the results. The table of the parameter set for the value of Kp, Ki, and Kd. So we have 5 condition. The first one is the initial condition, and the last one the condition without the PID. So these are parameters that we use to change the values in the transverse function. So next slide. So this figure shows the result of the condition 1 and 2. Next slide. Condition 3 and condition 4. And lastly, condition 5. So let's proceed with the discussion.
Okay, for this discussion, from the results from before, it can be seen that if we change PID parameters, which are proportional parameter, which is called Kp, integral parameter, which is called Ki, and derivative parameter, which is called Kd. It will affect the time rise, settling time, overshoot, and state error of the system. Okay, Kp is a product of gain and measured error. This means if the larger Kp or the error, it will result in a larger output from the Kp itself. Okay, moreover, if the Kp is set too high, it will lead to oscillation due to repeated overshoot. As for the Ki, it increases the action of the error as well as the time. If the force is insufficient to reduce the error to 0, the force will be increased with time. As for the Kd, derivatives parameter, it focuses on the rate of change of error. The more the error change or derivative time, the larger the derivative factor will be. Okay, the effect of derivative is to counteract the overshoot caused by P and I. Okay, as you can see from the previous graph, we can see that for the condition 1, the parameters are the same as condition 5, but condition 5 has no PID, while condition 1 has PID. The graph for 1 is oscillating, and it eventually becomes a straight line as the time goes by. While the graph, the graph for condition 5 is it rises for the at the beginning before it becomes straight line. Okay, as for the condition 2 and condition 3, the graph is almost the same, but the y-axis for both graphs are different, where the y-axis for the condition 3 is lower compared to the condition 2. Okay, as for the graph 4, the condition graph for the graph 4 is almost the same as condition 2 and condition 3, but there is a slight difference in the y-axis. That's all for discussion. Next.
So to conclude, all the components that have been used in the simulation are functioning very well, as the result can be obtained after changing the parameters involved, as Alif has presented in the discussion. So with the presence of the PID controller, the water level rise is successfully controlled and the water level measurement is obtained accurately. So I think that's all from our group. So thank you.
Thank you,
very much.
everyone.